Hello everyone, this is the Unit 2 Algebra review sheet, and we are going to cover a lot of different topics, so let's get right to it. Topic 1 is equation of a line including slope and y-intercept. The first question says find the slope and y-intercept of to the linear equation below. And so the first thing that you do have to do is remember that it is supposed to be in y equals mx plus b format for you to get the slope and the y-intercept. So you have to solve for y. And the first way you do that is to add 4x on both sides. Once you add 4x on both sides, you're almost there, but you're not quite there. That you have 8y now equals 4x plus 24. Once you have that, then you divide by 8 on both sides, and you will get y equals, and just take a look, this is kind of like the butterfly method there that you divide with. That 4 over 8 is 1/2 x. Bring down that x. And then you have 24 divided by 8 is 3. So you have a slope of 1/2. That y equals mx. The slope is the one that is the number that is the coefficient that is right next to x, and the y-intercept is 3. Nice easy question for the number 2. Find the slope of the line that passes through that 1, 6, and 3, 16. So you're going to label x1, y1, x2, y2. So we have m equals, and then the formula for slope of 2 points, when you have 2 points, is y2 minus y1 over x2 minus x1. And the slope formula for a graph, when you have a graph, it's rise over run. The y2 minus y1 is the rise. The x2 minus x1 is the run. So we're going to take y2, and we're going to set it up like this. When these minus signs are from the formula itself. Very important to do that. So y2 is 16, y1 is 6, x2 is 3, and x1 is 1. So we have m equals 16 minus 6 is 10 over 2. You could put this directly into your calculator. The calculator will give you 5. So the slope is 5. Number 3. I think the easiest way to do this, and I'm sure there's other ways to do it, but it says the points 4, 1 and x comma negative 6 lie on the same line. The slope of the line is negative 1. So I'm just gonna say, like, this is really important stuff. What is the value of x? So they're asking you to kind of like substitute in sorry. If you have negative 3 in here as the x, and then figure out the slope, you would say, okay, that doesn't equal negative 1 if you figure out the slope. And you have to find one of these numbers when you substitute it in for x that will equal negative 1 as the slope. So I'm going to start off going like m equals y2 minus y1 over x2 minus x1. Right? And that is the first thing that I'm going to do. And I'm going to put x1 and y1, x2 and y2 down. All right, so I'm going to put m equals, and I'm just going to set up my formula, and I'm going to put y2, which is negative 6, minus 1. And then I'm going to put this x. Now, I have a number that's missing there. All right, and then it's minus 4. So I'm just going to figure out the top part, the numerator. So the numerator is negative 6 minus 1 is negative 7. Remember, it's supposed to equal negative 1 as the slope. So either I could go ahead and substitute each one of these in for this missing question mark right here. And I should put a question mark instead of like a line. So this is a question mark right there. So if I put 3 in, negative 6 minus 1 is negative 7. 3 minus 4 is negative 7. So if I get a negative 7 down here, negative 7 divided by negative 7 does not equal negative 1. It equals positive 1. Negative divided by negative is positive. So that means this can't be 3. Like this question mark can't be 3. I don't need a negative 7 down here. I need a positive 7. Because if negative 7 divided by positive 7 equals, if negative divided by positive is negative, that means this question mark with this whatever it is, this number, minus 4 has to equal 7. And the only one that does that is D, 11. And I'll prove it to you. I'll erase this question mark, and I'll put in 11 there for you right here to show. All right, so 11 minus 4 is 7. Negative 6 minus 1 was always negative 7. Negative 7 divided by positive 7 is negative 1, so D is my answer there. Okay, it's a little bit of trial and error, but you could definitely get it. This is a very easy question, especially if you have a calculator. All right, if you have a calculator, this is no joke. You just put this into the calculator and you will go, I don't know what happened there. We're going to just bring up the wrong calculator and we're not doing well. All right, so take a look at what I'm going to do. First off, I don't want to show you the calculator right now, but you do have a calculator. This is a 9th grade test. All right, so this is an input. I'm going to the positive numbers, and this is an output. So this is my X. So if I take, I'm just going to go down to C and just start with C. So if I take 5 times 0 minus 2, I have 0, 5 times 0 is 0, minus 2 is negative 2. I'm substituting the X into this equation, and I'm supposed to get negative 2. It says 5. I know C is out. Then I'm going to the other positive. So I'm going to try 2 times 0 minus 5. 2 times 0 minus 5 is negative 5. I'm supposed to get positive 5. That's out. So now I'm forced to go with A, and I'm going to try A. So this was C, and then I tried B. And I'm just trying them in that order because I think it's a little bit easier to deal with the positive, like positive times whatever, positive numbers. So I have A. So it's y equals negative 2 times 0. So we know that's going to be 0 plus 5. That equals 5. That works out. I'm going to try another one because I think A might be my answer, but let's see. Negative 2. And instead of 0, I'm going to put 1 in. Plus 5. If I put this directly into my calculator, times 5, right? Plus 5. Negative 5. Negative 2 plus 5. No, negative 2 times 1. Sorry. I'm losing it. Negative 2 and times 1 plus 5. Enter 3. Let's see. 3. So now that equals 3. So far I have 2. I'm just going to check one more. Negative 2 times 2 is negative 4 plus 5. Negative 4 plus 5 is 1. I'm good. A is my answer. And when I said the graphing calculator could help you out, I really meant it. So I'm going to bring the graphing calculator up, and I'm going to use what I would do in the 9th grade. And if I had a graphing calculator, I would press y equals, and I would clear out whatever I had there. And I'd start putting the equations in, negative 2x plus 5. Once I have the equation in, I could see what the graph looks like, and the graph looks like that, but I don't care what the graph looks like because I need the table of values. So I press second function in graph, and see these values here? So we have right here, negative 2, 9. So to get the negatives, I'm going to go press up, and you can see negative 2, 9 right there. The next one is negative 1, 7. I have that. 0, 5, 0, 5. 1, 3, I have 1, 3. And 2, 1, I have 2, 1. This is the line. So if I put another line in, if I try any other line, it won't match up with the coordinates. So we know that A is the answer, just happens to be the answer. It's the first one that I put in. It's when you press y equals, you put that equation in there, and then you press second function graph to see the table of values. And that is basically it. All right, so A is your answer there. You could do it one or two ways. Without the graphing calculator, you would have to do it by hand. When you have a graphing calculator, you don't have to do it by hand. All right, number 5. Number 5, what is the equation on a line? They give you the equations there. It's y equals mx plus b, right? So the first thing that I'll look at all the time is the b. So I'm just putting this right here as my y-intercept, and I have 8. So out of that, like just that information, I could cancel out 2 possible answers. So I have a y-intercept of 8, A is possible answer, and a y-intercept of 10, nope. A y-intercept of 8, yes. A y-intercept of 10, no. 2 answers gone. 2 possible answers left. This line goes down from left to right. I know it goes down from left to right. Let me check my slope. I have a negative slope here, and I have a negative slope here. So that means both of them are negative. Sometimes they give you negative and positive, and you can cancel it out without even getting the slope, without even figuring out the slope. I have to figure out the slope here. So this is a perfect point. Remember, when you pick points, that you have to pick the an integer point. So in other words, a whole number has to be in a corner of a box, has to be exact. So this is 0, 8. That's why I'm picking that. So now I'm going to go and scan. See this point right here? That's no good. This point's no good. This point's no good. This point's no good. And look, I have to go all the way down to the x-intercept to figure out, all right, that's a point I could use. So I'm going to go ahead and draw my triangle. And now I have to watch out. This is going by 2s. This graph is ridiculous, but they put it on the state exam last year, the 8th grade state exam. It fooled a lot of people because it looks like 4, right? So, but it's not 4. It's 1, 2, 3, 4, but it's going by 2s. So you have to count by 2s. 2, 4, 6, 8. Since it's going down, I'm putting negative 8. Now, going from 0 to 10, 2, 4, 6, 8, 10, I'm going to go 10. So my slope is negative 8 over 10, and then I'm going to reduce that to negative 4 over 5. It's not negative 5 over 4. Remember, rise over run. So this is your answer. So if you ever wondered, like, hey, like if you have trouble reducing fractions, you could put the fraction in. Remember, you press alpha x and you get your fraction symbol, and you put the negative 8 over 10 in. You press enter. It'll automatically, it's great about this calculator, is that you don't have to press the simp button on the, like on the 8th grade, the TI 34. You have to press the simp button. It gives you an arrow down. This does not give you an arrow down. You just press enter, and it's negative 4 over 5, and that is your slope. This is your equation. You're done. So number 6, the values given in the table below lie on a graph of a linear function. They're telling you that it lies on the graph of a linear function. Use the point slope formula to write the equation of this linear function. So the point slope formula is y minus y1 equals m times x minus x1. So obviously you have to find the slope. You already have some points, but you have to find the slope. So let's go ahead and label this x1 and this y1. And this x2, this x2, this y2. So I'm going to figure out the slope up here. And the slope formula is y2 minus y1 over x2 minus x1. we have subtraction, 1.75 minus 1.00, and then 0.50, x2 minus x1, 0.25. I'm going to grab my calculator, and I'm going to move this over, hopefully, and we're going to press alpha x, and going to put 1.75 minus 1. And you have to put 1.00. The calculator knows. It is 0.5, 0.50, 0.5 minus 0.25. And you press enter, you get 3. So the m is 3. That's nice. So the slope is 3. So now we're going to put it into the point slope formula. Y minus, I'm going to use my x1 as 0.25. And I'm going to use my slope and of what I got, there's 3. And then x minus 1, because that's the y1. Ooh, sorry, made a mistake. Y1, don't know why I did that, is 1. That's what happens when you're trying to go fast. X1 is 0.25. Y minus y1, y1 is 1, equals m times x minus x1, which is 0.25. All right, so this is, right now, let me move this over because this is bothering me already. Move this over. Let me move this over. Okay. I'm going to put down what this is. This is point slope form. That's the point slope form. If they wanted the equation in point slope form, they would tell you. Usually, the equation of a line is in slope intercept form, when you have the slope and the y-intercept in the equation. All you have to do is actually just solve this for y. So I'm going to solve it for y. Y minus, I'm just going to rewrite it, 3 times x minus 0.25. So before doing anything, I am going to distribute. I'm going to solve for y here. Y minus 1 equals 3x. And then just so I know I'm getting this correct, 3 times negative 0.25. All right, and that is negative 0.75. Then I'm going to add 1 on both sides. And I'm going to cancel it out. And here is my equation. 3x plus 0.25. That is my equation of the line in slope intercept form. All right. Which function of x has the greatest value? That's the second time that happened to me. The greatest value of the y for the y-intercept. Greatest y-intercept. So we're just going to go and we're going to figure out what that y-intercept is. So b equals 15. That's pretty great. B equals negative 3. B equals negative 2. It's a pretty easy question. B equals 2. What's the greatest? 15. That's it. The greatest value for the y-intercept has nothing to do with the slope. That's it. Number 8. What can you conclude about the graph of a line that is given by this equation? What can you conclude? The line has a slope of 3. No, it does not. The line has a slope of negative 3, so that's out. The line has a y-intercept of 0, negative 3. Yeah, it does. Actually, b equals negative 3. And negative 3 on the coordinate plane, and that's like a little sketch here. I'm famous for my sketches. I don't know if you know that. -3 right here, right? So that is 0, -3. That's the y-intercept. So this is true, but I'm going to pass it right now, so that could be the answer. The line passes through the origin. The origin is 0, 0. For that to be true, this has to be a direct variation, and the b is not going to be -3. The b is going to be 0. The line rises, so this is false. The line rises from left to right. Rises. If it has a slope of -3, it goes down from left to right. So this is false. The only one that's true is B, so B is your answer. Number 9. On the set of axes below, graph the line whose equation is 4x equals -8x minus 12. So obviously you have to have this in y equals mx plus b. You need two things. You need the slope and you need the y-intercept. You notice that the graph has no numbers. It's because it's a 9th grade graph. And now you could go ahead and divide by 4. Divide by 4. Y equals -8 divided by 4. -8 divided by 4 is -2. And then -12 divided by 4 is don't forget the x, by the way, I almost forgot the x, is -3. All right, so the m is, and when you're graphing, please put it in rise over run format. Rise over run format. Just put a 1 underneath there, right? So you're going down for the rise because it's negative, and you're going to the right because that's positive. That's the run. Going to the right is positive. So then you have a b of -3. This is your y, this is your x. Let's start. This is the y-intercept. I'm going to go down from 0, 0 to -3. So I count down to -3, put a nice big point. Then I'm going to go down 2 and to the right 1. I'm using my directional arrows, going down 2 to the right 1. Down 2 to the right 1. And then up 2 to the left 1. Up 2 to the left 1. Up 2 to the left. Up 2 to the left. Up 2 to the left. And you keep on going. You fill in the whole graph until you can't go anymore. Then you take your ruler and you draw a straight line. Remember to put arrows on each end of that line and then put the equation in y equals mx plus b format on the line. And probably on the top would be best, because when we start graphing inequalities, you don't want the equation in the middle of the graph. So it's right there. So this is what you check after you finish. You check to see if the equation, the slope is going down from left to right because you have a negative slope, and you check if the y-intercept is -3, that it crosses at -3. It does. We can move on. And that is your line. So the linear equation contains the point 3, k. So state the value of k. You could use the graph. So 3 right here, the value of k is 1, 2, 3, 4, 5, 6, 7, 8, 9. And remember, that's -9. So the value of k equals -9. When x is 3, y is -k. -9. It sounded weird when I said it. But anyway, k is -9, and that is your answer, and that is the whole question. Okay, so topic 2. Thank goodness. That was a long topic. So in City W, the average cost of a gym membership is given by the equation this. So where the Y is the total cost. Y is always the total cost in dollars for X month of membership. So what's the sign up fee? So the M is the slope, is the rate. That's 34. It's the number always before X. The y-intercept, the initial fee, the sign-up fee is $49. Before we even start a month of a gym membership, I don't know why you would want to join a gym, but if you do, B is, it's going to cost you $49 to join the gym. That's the sign-up fee. So that means it only occurs once. You only pay that $49 once. What's the average monthly cost for the gym? The average monthly cost is $34.99. And that is per month. How much does the gym cost after 1 month? Not for 1 month, after 1 month. How much does the total of the gym cost? So what you would have to do is you would have to just put the Y equals $34.99 times it by 1 for 1 month, X plus 49. Grab your calculator, and you're going to put $34.99, use your calculator for everything, times 1 plus $49. And that would be $83.99. After 1 month. What about after 2 months? All right, go back to your calculator. Now you're going to take the same equation, $34.99, instead of 2 months, instead of 1 month, you're going to put 2 in for X. And after that, $118.98. So I'm going to put that down, $34.99 times 2 plus 49. I forgot what. $118.98. And that's after 2 months. Okay, so number 2. The cost to rent a boat includes an initial fee. Initial fee of $20 plus $2.25 per hour. Write an equation that models that relationship. So first, put the M down. Put the B down. What's the initial fee? The initial value, the y-intercept. That's $20. Per the monthly charge, the hourly charge, I should say, is that. What's the equation in y equals mx plus b format? When you put the equation down, make sure you put the y equals 225x plus 20. All right, next one. Satellite television company charges a one-time installation fee and a monthly charge. The total cost is modeled by this. That's the whole thing. Identify the slope and the y-intercept. The number before x is the slope. The other number is the y-intercept. The slope is 90. The y-intercept is 40. The cost of renting a moving van can be modeled by this. You notice I'm using a highlighter all the way. Where y is the total, remember, y is always the total cost. After the equal sign is the total cost. The miles for driving is m. State the meaning of the slope and the y-intercept in this function with respect of the cost associated with the van rental. So now this is like where you have to have words. All right, so, but I'm just going to keep on, I'm going to do what I normally do. I'm going to put down the M, and I'm going to put down the B. So here it is. I wrote it down. I typed it out. The slope of 350 stands for the dollar 300. Sorry, $3.50 stands for the cost of renting the moving van per mile. Right. The y-intercept, which is 19.99, represents the initial cost of the van before driving, and that's basically what you would have to say. All right, and that is that. All right, Corey drinks water from a bottle during a bike ride. The average amount of water in ounces is what a bottle can be represented by this, where Y is the amount of water that is remaining after X hours. Based on the equation, what amount of water in ounces will remain after Corey rides for 2.5 hours? So very interesting question, and I'm going to start off with y equals negative 8x plus 32. And if y is the amount of water remaining after x hours, they want to find out what amount of water in ounces will remain in the bottle after Corey rides for 2.5 hours. So the x represents the amount he's riding in hours. So what I'm going to have to do is just substitute into this equation, and instead of 2.5, I'm just going to put 2.5. So calculator, clear this out. Negative 8 times, and let me just get this right, 2.5 plus 32. 2.5, close the parenthesis, plus 32, and we'll see how much is remaining, 12 ounces. So y equals 12 ounces remaining. So he has 32 ounces. He starts with 32 ounces. That's the initial fee. So the initial fee. That's the initial amount of he has in the water bottle, 32 ounces. After a 2.5 hour ride, he only has 12 ounces remaining. And B is your answer. Pretty good question. Like that question. All right, a company that manufactures radios first pays a startup cost and spends a certain amount of money to manufacture each radio. If the cost of manufacturing radios is given by this, and 125 best represents, you know that the 125 is the B. So remember, the B is the initial value, the initial fee, the startup cost. So it's the startup cost. It only happens once, that startup cost. The profit earned from the sale of one radio? No. All right, has nothing to do with profit of one radio. The amount spent to manufacture each radio? No. First pays a startup cost. First pays a startup cost. That's the startup cost. Then spends a certain amount of money to manufacture each radio. That's this. All right. The average number of radios manufactured? No. So A is your answer, and that is that. Number 7, Alex opened a savings account with an initial deposit of $50. That's the initial deposit. He deposits the same amount of money. He uses this equation to determine T, the total amount of money a savings in account in M months. What's the unit rate, and what is the meaning of the unit rate? So I'm not even talking about the initial deposit. They're talking about the unit rate. The unit rate is the slope. So unit rate is 25. So we could cancel out 50 and 50 because the unit rate is 25. Only people that are going to pick 50 are people who are confused about which number is the unit rate and which number is the initial deposit. All right, so we have 25 for A and 25 for C. So now we have to read the amount of month Alex deposit each month. I don't know, it's supposed to say the amount of money Alex deposits each month. So He opens up a savings account. When initial each month he deposits the same amount. So amount of money Alex deposits each month. The amount of money Alex initially deposited. The amount of money, 25 does not stand for the amount of money Alex initially deposited. 50 is the amount of money that was initially deposited. So this is out. Amount of money he deposits each month is A. A is your answer. The graph of the linear function y equals mx plus 6 passes through the point -3, 0. Which statement is true? All right, so I'm going to write this down. Y equals mx plus 6. And the y could be, because it's 6. And I'm given -3, 0 as a point. The y-intercept is 0. Is the y-intercept 0 if this is 6? That's out. The y-intercept is 3. I already proved that the y-intercept is 6. So b equals 6. I know that. That's out. Slope is positive. Slope is negative. I have no idea. So what am I going to do? To figure out slope, how many points do we need? We need 2. We only have 1. Do we? All right. Let me see. I have 1 point here, -3, 0. If this is my y-intercept, can we make another point out of my y-intercept? Remember, the y-intercept is here. Let me sketch it. You know I love sketching. 6. That's this point. What's the x? 0. So 0, 6. When they give you the y-intercept, they're giving you an x of 0. So let's see. x1, y1. x2, y2. So m equals 6, y2 minus y1 over x2 minus x minus -3 plus 6 over 3. The m is 2. The slope is positive. If you did not want to do that, see my little sketch down here? This is the y-intercept. Look at the y-intercept, it's 6. You see this other point? -3, 0. See that line? That's a bad line. Mr. Viola. See that line? Is that positive or negative, that line? So you don't really have to go through the slope formula if you don't want. It's positive. You could sketch the graph and figure out if it's positive or negative. After knowing that the y-intercepts were not, the y-intercept is not 0, not 3, you could just sketch it. Number 9, write a line that is parallel to y equals 3x plus 1. Parallel lines always have the same slope. Different y-intercept. So write a line that is parallel. Y equals 3x plus 6. Y equals 3x. Y equals 3x minus 3. All these are parallel, same slope, different y-intercept. Write an example of a direct variation equation. Remember, direct variation must have a y-intercept of 0. Y equals 2x. Or y equals half x. Or y equals -6x. How can you tell an equation is a direct variation? The y-intercept is 0. How can you tell in a graph if the equation is a direct variation? It is linear and crosses through. 0, 0, which is called the origin. All right. Line N passes through the points 3, 7, and 2, 5. Dahlia determined that the equation of the line N is y. Oh, let me get my highlighter right here. Okay. So explain the error Dahlia made. Okay, so y equals she's saying that it's y equals negative 2x plus 1. Dahlia's determined that the equation of this line is there. Explain the error that she made. All right, so I'm going to figure out slope because slope is easy enough. M equals, let's see, y2 minus y1 over x2 minus x1. And I'm going to put this as x1, y1, x2, y2. M equals 5 minus 7, 2 minus 3. So M equals, all right, so like I'm going to put this into my calculator, 5 minus 7. I could do that really in my head, but I'm just going to do it 5 minus 7 and 2 minus 3. 2. So my slope is 2, and Dahlia said negative 2. So I'm going to write that Dahlia made the mistake of putting a negative slope when it was a positive. And I just put down there, Dahlia made the error that when she calculated the slope as negative 2, when it should have been a positive 2, that you could see clearly that 5 minus 7 is negative 2, and this is negative 1. Negative 2 over negative 1 is positive 2. She put negative 2. Ain't that no good? All right, number 3, scatter plots. So you know that most of the time that you do have to create a trend line. So these data are modeled, the scatter plot's given, and is modeled by this line, y equals negative 5.9x plus 850. Identify the slope and the y-intercept and what they mean in the context of the problem. So you really don't have to draw the trend line. I'm just going to do it just because. So there, right there, like would be a perfect trend line. Down further at 850, you see that it goes 850 is down and it's negative. So the slope is negative 5.9 fluid ounces, and it means that the coffee sales, all right, so obviously it's decreasing. It means that coffee sales are decreasing as the temperature goes higher. All right. So this is what I wrote. The amount of fluid ounces sold decreases negative 5.9 ounces. I got that right here. Every 1 degree increase. All right, for every 1 degree increase. You could actually just put for every 1 degree increase. And the y-intercept is actually right here. You know what that is right here. This is your y-intercept. This is 850. So starting that initial rate, we go 850 means that 850 ounces of coffee was sold initially. It's the initial fee. It's the initial starting amount, and not the initial fee, but starting amount. All right. So draw a line of best value. Oh, wow, it's the same graph. All right, and we're going to draw that initial, trend line. And that's nice. This is the same one. So I already did it up there. All right, what type of correlation does this graph represent? So this is a negative. So we're going to just kind of put down, it's definitely linear. We could say that this is kind of like, they're not going to ask you strong or weak, but it might be a little weak, right? Because it's not so much clustered around, but I'm not even going to say, but if you say strong, I would kind of like, okay, maybe it is strong a little bit, but I'm going to put weak. Negative correlation. I think the big thing there is that you know that it's a negative correlation more than anything else. And it's definitely linear. Predict the amount sold in fluid ounces when it's 70 degrees. So the way you do this is that you go to 70, put a dotted line up to your trend line, and then it stops right there at the trend line, and then you go across. So at that trend line, I'm going between 400 and 500, and that is 450 ounces. And that's how you predict using your trend line. As part of a training program for a triathlon, Marcy completes a 3-mile run. Good for Marcy. A few times each week, scatterplot shows, blah, blah, blah. All right, draw a line of best fit. We know that we have to draw a line of best fit right here. That, I'm going to move that down a little bit. I'm going to start it at 30. I'm going to move this down just a little bit. That is the center of all the points as best as I possibly could. And you know, like I always try to start at a whole number. This one works out well. So we're going to try to put down a y-intercept and slope. And since I started at 30, it's pretty good that the slope, that I know that the slope is 30. And then I'm going to pick 2 points. I'm going to just go along my line. And I'm going to pick this one. And I'm going to pick this one. So this is my trend line. And since this is 25, right? This is 1. And this is 1. So my slope is 1. M equals 1. So it's 1 minute every week, 1 week. So I like to put words there to kind of know what it is that they're talking about. So 1 minute per week. So explain what the slope and y-intercept mean in the context of the problem. Okay, so I put it down here, I typed it out, and now I'll read it to you. The y-intercept of 30 minutes is her initial time for a 3-mile run. And this is basically weeks in a training program. So the weeks, as the weeks go on, she's decreasing the amount of time that it's taking her to finish this 3-mile run. So a slope of 1 minute, the slope means that of 1 minute per week that I have, means that every week that she's in training, her time decreased by a minute for running those 3 miles. So every week she's in, it decreases another minute. It decreases another minute. It decreases another minute. It decreases another minute. And as the weeks go on, that's exactly what I found. So that's about it. All right. If you got like a slope of like 1.3 or like, that's fine too. My trend line just happens to go there, and that's it. All right, and that's about it. Which statement best describes a scatter plot where the y values are increasing as the x values are y values are increasing as the x values are increasing. I am going to put a scatter plot together just like this. All right, and these are the y values. They're increasing as the x is increasing. So I'm going to put a scatter plot, just all scattered, 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 scattered. I'm drawing my scatter plot. As the x is increasing, the y is also increasing. So increasing, increasing. The data can be best modeled by a vertical line? No. The data can be modeled by a horizontal line? No. The data can be modeled with a positive slope? Yes. And this is not a negative slope? No. So C is my answer, negative slope. Positive slope. Going up from left to right. Scatter plot to the right shows the number of milligrams of a medication in a person's body for the first 3 hours after medication is given. Which kind of correlation does the scatter plot show? I am just going to draw my trend line, just like that. And obviously that shows a linear, negative, you can put, okay. It's linear and negative. It's also strong. This is strong because they're so clustered around that trend line, and negative. Association. So I'm going to get that trend line out of there for now, because it's telling me now to find the linear regression equation to the nearest tenths. So I am going to have to actually put this into the calculator. And so we are going to kind of space this out a little bit. And we are going to press second. We're going to clear this out. We're going to press stat and enter. I have list in there. So I'm going to go up to L2, press clear, press enter. I'm going to go up to L1, press clear, press enter. Okay, so now this right here, I'm just going to go right here. This is 0.7 about 112. 0.7 for the x, and I'm going to have to put the y in as 112. And then I'm going to go to, this is basically 1. I could even say it's 1.1, let's say. I could say it's 1 though. And it's 87? 86? 86. So this is 1.1. Enter. That's the x. The y is 86. Like I said, your numbers might differ from mine. This is definitely 1.5. And this is really close to 70. But it's like right in the middle is 60. So right in the middle of that is 65. So 1.5, 65. 1.5. And then 65. Enter. All right. We're getting there. This is 2. And right in the middle is 40. This is 2.5. 28. 2.5. See, now that's the x. I press clear. Clear that. Sorry, delete. All right, so this is 2.5. Messed up there, see? 2.5, now go over to the y, and that is, what did I say? It was like 28. That's the y. Go back over to the x. The last one. 2.910. Enter. 10. I have the same amount of numbers. I have the same amount of numbers on the x, same amount of numbers on the y. Now I have to get to the linear regression equation. I press stat, go to calc, press 4 for linear regression equation, and I'm going to press enter 5 times. And there is my linear regression equation. Because I have diagnostics on, I'm seeing the correlation coefficient. So, but I'm not worried about that for this one. This is the slope, the A. So I'm going to write down right now what my A is. I'm going to put it over here. A equals negative 44, and it should be negative. It's going down, 0.955. And the B is 137.00. All right. So find the linear regression rounded to the nearest tenths. So I have y equals, so I have my A as negative 44. That actually does go up to 45. Because see this, like negative 44.9, this next number right here is 5. That turns that to a 0, and that will turn that to a 45. So I'm going to round it to negative 45. X, and then plus nearest tenths is 137. Find the correlation coefficient. So it does ask. So remember, correlation coefficient, the easiest way to turn it on, the easiest way to actually check if it is on is by pressing mode. And you see this stat diagnostics. Stat diagnostics is on for mine. So usually when you reset your calculator, it is off. So if you see that, like not blinking, if you see this off right now, you have to go down to the off, press to the right, then press enter, and it is on. Then you go down one, and you can tell that it is on stat diagnostics. And by the way, you'll know if stat diagnostics is not on because when you press stat and then you go to calc and you press 4 and then you press down enter, 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 if stat diagnostics is not on, you will not see the R. It'll stop with A and B. So I am going to put an R of negative 0.99. Round to the nearest hundredths. So R equals negative 0.99. So they usually ask a question, a backup question, is like, what does that correlation coefficient tell you about the this whole trend line? So this is a backup question that they did not ask that I would like you to understand and know that this is definitely, they're not going to ask you just for the correlation coefficient. They're going to ask you what that means, it represents in this case. So the correlation coefficient of negative 0.99 represents a very weak negative correlation between the x-axis and the y-axis, whatever they say. All right, so the x, which is hours since medicating, and milligrams of medication in the body. I'm just putting the words down that are on the graph. So don't overthink it. The correlation coefficient of negative 0.99 is very close to negative 1. And just remember that I did, when we went over in class, we have this right here, that we have this, this graphic, that it is a weak negative from 0 to 0.5, a weak negative from 0 to negative 0.5, and weak positive from 0 to 0.5, and then from negative 0.5 to negative 0.8 is a moderate negative, and positive 0.5 to positive 0.8 is it's a moderate positive. And then you have a negative 0.8 to negative 1 is a very strong negative, and that's basically what we're saying right here, because a negative 0.99 is a very, very weak negative. Sorry. very strong negative. I meant to put strong. So we have, when it's close, you have to change this to strong. All right. So very weak negative would be closer to 0. Very strong negative is exactly what I have right there as far as what that we have for the correlation coefficient as -0.99. Very strong negative correlation between hours since medicating and milligrams of medication in the body. All right, sorry for that error. That's it. Very strong negative is closer to -1. Very strong positive is closer to +1. All right, so that's basically it. This question wasn't asked, but it could be. All right, it could be and probably will be if there's a Regents question like this. Oh, there we go. All right, because I didn't see, I put it in the other part of this. So I'm just going to go back and I am going to put this right here. All right, so what does the correlation coefficient suggest in the context of the problem? The correlation coefficient of -0.99 represents a very strong negative correlation between hours since medicating and milligrams of medication in the body. That is basically it. All right, so topic number 4, graphic interpretation, my favorite topic. All right, so number 1, the graph of a function is shown below. Describe each section as linear and nonlinear, increasing, decreasing. Section N is increasing. And linear. It is a straight line and it's going up from left to right. Section P, same thing, increasing. And linear. Section Q, not increasing or decreasing. All right, so what is the slope of that? Slope is 0. All right, so slope is 0, and that means that it is a horizontal line. The slope is 0, horizontal line, and it is linear. Section R, increasing. And linear. All right, and that's basically it. Which graph shows a function that in which the rate of change and the y-intercept are both negative? So, rate of change and y-intercept are both negative. This is a positive rate of change. So that's out. This is a positive rate of change. So that's out. This is a negative rate of change. This also is a negative y-intercept. So that means C is your answer. That is not. 0 is a y-intercept there, and it is not negative. Number 3, which graph? The graph of a function is shown below. For which interval x is the function increasing and linear? So just take a look here. So this is not a difficult question. So increasing and linear. So this is increasing and linear right here from -4, around -4, and -2. Okay, let's see. So maybe -2 to 0 is here, right? -2 to 0. That is nonlinear. It goes this way. So that's out. Between 0 and 2, you see this curve? That's no good. That's out. Nonlinear. Between 2 and 4, that is going down. Down between 2 and 4, they want increasing and linear. Between -4 and -2, it's increasing and linear. That's it. Goes up and is straight. That is it. John left his home and walked 3 blocks to school, shown in the accompanying graph. Explain where John was walking the fastest and how can you tell? Well, you're talking about here to A, right? Then A to B, and then B to C, not walking at all, distance, this is distance, and then C to D. Where's he walking the fastest? The steepest line is where he's walking the fastest. So from A to B, John is walking the fastest. He's walking at the fastest rate. The line shows the greatest, the steepest incline. So that's really what you put for that. Number 5, the graph below shows a jogger's speed during her 20-minute jog around her neighborhood. Which statement best describes what the jogger was doing during the 0 to 2 minute interval of 0 to 2 minute? She was standing still? No, she was standing still. She's gaining speed. Like, see, this is speed. She was increasing her speed. All right. She was decreasing her speed. No, she's not going down. This is a decrease in speed down here. So that's out. She was jogging at a constant rate. This is the constant rate. That's a constant rate. This is a constant rate. This is a constant rate. This is a constant rate. Increasing his speed was right here. And B is your answer. And that's it. All right, so topic, linear regression, correlation coefficient, and residuals. Describe the steps for finding the correlation coefficient on the graphing calculator. Okay, this is describing the steps for finding the correlation coefficient on the graphing calculator. Make sure to turn Stat Diagnostics on first by pressing Mode and then going down to Stat Diagnostics and highlighting On and then clicking Enter. Then you go to Stat, Edit, and then you input your list into L1 and L2. Then you press Stat again, go to 4 for linear regression, AX plus B. Press Enter 5 times, and R is the correlation coefficient. Those are the steps that you take. Explain how you can tell if a line of best fit is a good model for the set for a set of data by looking at it, just by looking at it. So explain how you can tell if a line of best fit is a good model. Well, when you're looking at the correlation coefficient, if it's close to 1 or -1, it is a very strong or very weak, very strong positive or very strong negative correlation. All right, so if it's close to that +1 or close to that -1, that is a good thing, and you can tell a line is a good model. That line of best fit is a good model. And when you're talking about a residual plot, we're talking about a plot must be even, like all the points, have to be evenly dispersed around that residual plot for it to be a good fit, for that line to be known as a good fit. If you see a U shape, it's kind of like the trend line not making any sense through the scatter plot. Like we've seen in our class, like where the trend line was drawn in an example that really isn't a good fit. That would be a U shape on the residual plot. That would show that U shape, and that U shape would mean that it was not a good fit. So, and that's basically it for that right there. All right. The following table represents a sample of sale prices in thousands of dollars and the number of new homes that priced in 2017. Write the correlation coefficient for the line of best fit. Round your answer to the nearest hundredth. So put these numbers in. Just remember, we're going to just go ahead and I'm going to do it off screen. So you guys do it when you press pause. And this is my don't know why I put an X1. This is my L1. This is going to be my L2. So put those numbers into the calculator and we'll come back and look at the correlation coefficient. So this question right here, the sales price, the L1 and the L2, I did that off screen. Hopefully you're able to do that. You press edit, and you press stat, and then you press, there's the edit, and you press enter, and you put your L1 in and L2 in, and then you press stat again. All right, once you press stat again, then you go to calc, and then you press 4. And right from 4, you're going to press enter for 5 times. And then your correlation coefficient will come up only if you have the stat diagnostics on. And remember, press mode, and you can see right from the start that stat diagnostics, it's on. So when you do go to calc, you will see that extra R there after the B and the A. The R squared and the R. The R is the one that you want. So we're going to go ahead and put down negative 0.95. And it says round to the nearest hundredth. So we're going to have negative 0.95. The next number after that 5 is a 4. So it stays a negative 0.95. Then it says, explain what the correlation coefficient means in the context of this problem. So this is it. The correlation coefficients of negative 0.95 suggests that there is a very strong negative correlation between sales price and number of new homes available. Just remember, when you're writing this, you're thinking about that this right here, where we're talking about negative 0.8 to negative 1 is a very strong negative. So just remember the correlation coefficient of negative 0.95 is in that very strong negative like little section there. That is also, now you just finish it saying that sale price right here, it's a strong negative, very strong negative correlation between sales price and number of new homes available. So you're using their words in their table and just throw it right back at them. All right, and that is basically it for that correlation coefficient. All right, the last question is to put a residual plot together. It is nice, this question, because they have it all set up for you already, and we're just going to go ahead and do it and plot that. So I'm going to take the tutor's hours, the X, and the residual. Remember the residual in class, we had to actually figure it out by subtracting the actual and predicted. We don't have to do that here. It's already figured out. So we have 1 to 7 that we have to cover, and I am going to skip 1, 2, 3, 4, 5, 6, and 7. And I'm just going to go up to 8 and 9. And then my residual, I have to cover all the way up to 6, negative 6.4. So I'm going to go 1, 2, 3, 4, 5, 6. If I go 1, 2, 3, 4, 5, I won't make it. So I'm just going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I'm going to go negative 1, negative 2, negative 3, negative 4, and all the way down to negative 10. All right, try not to put it in the middle of a box like I just did right there. I'm going to move this down just a little bit, and that's not the way I want it. Okay. So now we're going to go ahead and plot. So we have 1. When x is 1, the residual is 1.3. So 1, we're going over to the x. right here, and 1.3 would be right about there. 2 and then 1.9. So 2 and 1.9 right about there, just under 2. 3 and negative 6.4. So 3, negative 6.4 is right about here. 4, negative 0.74, and negative 0.7 would be right about here. 5 and 2, that's easy. Right there. Goodness. Okay, right there. And 5 and 2. 6 and 6.6. 6 and 6.6 all the way up here. 7 and negative 4.7 down here. All right, 7 and negative 4.7. Use the residual plot to assess the line of best fit for these residuals and justify your answer. It does not look like a U shape to me. All right, so you are going to put, is this, you're assessing the line of best fit. Is this a good line of best fit? Does it justify based on the residual plot? It does not make a U shape. So you are going to put the line of best fit is a good fit because the points are evenly scattered and I'm going to use randomly dispersed on the residual plot. The line of best fit, or you could say the trend line, or the line. The line is a good fit because the points are randomly dispersed on the residual plot. They do not make a U shape. They do not create a U shape. You don't have to put that last part. You're not proving that you know anything by saying that. Just say, just basically, the line of best fit, or the line is a good fit because the points are randomly dispersed on the residual plot. And that is it. And thank you for watching. Hope it helped. Take care.